Okay, so we're talking about getting another thread to interrupt another thread, and we talked about using the interrupt method to do that. So it means that we need to have a reference to the thread instance, and the easiest way that we can test this is to go back to our main class and interrupt the another thread class, because we've got a reference to the another thread instance there. So let's go back and do that. And what we'll do is, so we'll call the interrupt method just before printing the second line from the main thread. So just after the myRunnableThread.start, come down here and we'll put another thread dot interrupt, like so. And then on line 32, we've got our regular second printout from the main thread. But let's also go back and change the run method in another thread, because we want it to terminate if it does get interrupted. And to do that, it's quite simple. All we really need to do is return from the run method. So we want to do a return straight after we've printed out the message to say another thread woke me up. So we add the return there, which should immediately terminate the another thread instance. So let's go back to the main method and run this and see what happens. And you can see that it finished quickly, and we got the message here, another thread woke me up. And of course that message came from the interrupted exception that was thrown, the message there on line 17, and that came about because we used another thread.interrupt on line 30. And just to confirm, let's delete that line again now and just check that it still does do the interrupt correctly. So run that again now, and we should find that it works as it did before. Pause there for 3 seconds. 3 seconds have passed and we see the regular output, because this time it didn't get interrupted and didn't terminate, at least up until the point of printing that second message. Then of course it terminates because it's finished the run method. So we've seen that we can put a thread to sleep, and it's possible to get it to wake up periodically to see if there's any work for the thread to do. So let's say we've got a situation where we know that a thread can't continue to execute until another thread's terminated. Now, for example, we might know that there won't be any data to process until the thread that's fetching the data has completed executing. So in that scenario, rather than waking up the thread periodically to see if there's any data, we can join the thread to the thread that's fetching the data. And when we join a thread to a second thread, what happens is the first thread will wait for the second thread to terminate, and then it will continue to execute. So let's join the thread that we assigned to the myRunnableThread variable in the main class to the another thread instance. So the thread will then stop executing until another thread's terminated, at which point it's going to wake up and continue executing. Now the code that runs on the myRunnableThread is contained in an anonymous runnable object, and that's perfectly okay. It doesn't matter whether we join from a thread instance we created using a runnable or a thread instance we created using a subclass of the thread class. All we really need is a reference to the thread that ultimately we want to join with. So if we come back here and in the myRunnableThread, and after the first printout, we need to add a try catch. So it'll try, and we're going to type in here another thread dot join. Then we need to catch interrupted exception again. So catch interrupted exception, and we're going to print out in the same color for this particular thread, which is ANSI red, plus I couldn't wait after all. I was interrupted. And of course that will only happen if indeed it was interrupted for some reason. So again, what we're doing here is we're calling the join method of the thread that we want to join the current thread to. In this case, we want to join to another thread, so we call the join method using the another thread instance, and you saw me do that on line 27. And we'll notice that, again, as I mentioned, join can throw the interrupted exception, and that's because just like with the sleep method, join can terminate prematurely if this thread's interrupted by another thread. So when working with threads, we already know we can't guarantee in which order threads will execute. We also can't make assumptions about how long threads will sleep or wait. So really what I'm getting at here is there's really never any guarantees. Now when we run this code, which we're about to shortly, another thread will put itself to sleep. Because of that, we should see the code running in the myRunnable instance print hello. Then we won't hear from it again until another thread's woken up, which should be around 3 seconds. At that point, the myRunnable thread's going to wake up and continue execution, and we'll see that it'll print that it's running again. And of course, what I need to do to print that message is output it, which I haven't done yet. So I'm going to do that. ANSI red plus, and we'll put another thread terminated. So I'm running again. So again, what should happen is when we run the main method, another thread's going to put itself to sleep. Because of that, we'll see the code running on the my runnable thread instance print hello, the first part before the try. Then we won't hear from it again until another thread's woken up, which should be around 3 seconds. At that point, then hopefully the my runnable thread will wake up and continue execution. Then we'll see that print that I've just added on line 28 showing on the screen. So let's run this now. And we can see that that did work. We can see that we have obviously had the 3 seconds where another thread was sleeping, and we also had the my runnable thread printed out the first message, hello from the anonymous classes implementation. It then paused, and you notice that it didn't then continue and show the second message on line 28 up until we had seen that the another thread's 3 seconds had elapsed. So in other words, it did correctly wait for that to terminate before it finished itself off. And obviously this is quite a simple scenario, so we didn't really have any problems running this because we're not interrupting any of the threads. But what would happen if we join thread A to thread B and thread B never terminates? Well, what would happen is our application wouldn't terminate, and it would probably look as if it had actually died or crashed. So to prevent this situation, we can pass a timeout value to the join method. And you may have seen when I was typing in this method here, method here on line 27, there was an overloaded method there. So when you add a timeout value, thread A is going to wait for thread B to terminate or for the timeout period, whichever happens first. So in other words, if thread B hasn't terminated, when the timeout period's passed, then thread A will stop waiting for that to happen. So let's try this. We're going to go back and we'll put another thread to sleep for 5 seconds. So we'll go back and make that change. So I'll make that 5,000 milliseconds now, so 5 seconds. Then go back to the main. And in the join method on line 27, we'll use the overloaded method and we'll get it to wait for 2 seconds. And it uses milliseconds just as the sleep method does. So again, 2,000 being 2 seconds. And just to be consistent, if I close down the run window, it probably wouldn't hurt to put here another thread terminated or timed out, comma, so I'm running again. So if we do that, we'll run that, we'll see what happens. And we saw that another thread terminated or timed out, and so it finished early, and then we didn't actually change the text for this, but 5 seconds have passed and I'm awake. So remember when we changed that to 5 seconds in the another thread. But if we go back there again now and change that back to 3,000 and go ahead and remove the parameter from join again, we should find it operates like it did before. 3 seconds have passed and I'm awake, and then another thread's terminated or timed out, which is what we expect to happen. So obviously when we join one thread to another thread and the join times out, we have to handle that case in a real world application. For example, if the thread was waiting for data and the join times out, then we wouldn't have any data to process, and we'd have to somehow report that to the user, like error downloading or something like that. Now there are other methods in the thread class we can use, but we've covered the ones that we'll use the most. The only other one I want to mention is the set priority method, and we can use that to try and influence the order in which threads are run. But you should really regard setting a thread's priority as more of a suggestion to the JVM and the operating system rather than a command. In fact, some operating systems don't support this set priority at all and will ignore it. As usual, never assume that setting priorities will force threads to run in a particular order. It's really ultimately up to the JVM and the operating system as to how that runs. And just out of interest, to learn more about the set priority method and the other methods available in the thread class, check out the documentation, and I'm just going to bring that up on the screen so you can have a look. Paste that in. A little bit bigger so we can see it. And there's a link on the screen there. So do check that out to find out more about some of these other methods and also about the set priority method. Quite useful information there for you to find out a little bit more about the thread class. Okay, so that ends our introduction to threads and concurrency. In the next video moving forward, we're going to look at how working with threads can lead to nasty bugs that can be very difficult to debug, and ultimately show you how to get around those as well. So see you in the next video.